Before we do a couple of the problems on the worksheet for special right triangles, I just wanted to point out those relationships that exist in the two types of triangles and look at a couple of different ways that we can use that relationship to find different side lengths, whether it's a hypotenuse or one of the legs. Now with these 45, 45, 90s, as we've talked about, we can see that the legs both have the same length, and then the hypotenuse is root 2 times the length of the leg. So as you can see here in the first example that I have for you, if we're given that one of the legs here is 4 and we're trying to find the hypotenuse, we are just going to multiply by the square root of 2. So y is just going to be 4 times the square root of 2. Knowing that we can't multiply those values together because that's not just a 2. We can't do 4 times 2 because it's the square root of 2. Now this is actually the same type of problem here with the same values but reversed. If we were given the hypotenuse first, that 4 root 2. If we were given that first and we were trying to find the leg, we're doing the reverse of what we did previously. In the last problem, we saw that we had to multiply by the square root of 2 because we're going from the leg to the hypotenuse, but here we are going from the hypotenuse to the leg, and therefore we have to do the opposite of multiplying, which is dividing. So we are just going to write down here 4 root 2 divided by root 2. And in this case, the square root of 2's cancel out, leaving us with just 4. So we can see both of those problems are really the same, but in the first one we had to multiply to go from the leg to the hypotenuse, and in the second one we went from the hypotenuse to the leg, so we did the opposite of multiplying, which is dividing. Now let's move over to the other type of special right triangles, which is 30, 60, 90. The legs are not the same length here. You can see that we have that short leg, which is across from the 30-degree angle. We have that long leg, which is across from the 60-degree angle. And then the hypotenuse, as you already know, is across from the right angle. Now everything here can really be based around the short leg length. Whatever that short leg length is, the hypotenuse is just twice that length. And the long leg is root 3 times the length of the short leg. So that's why you can see our short leg is just represented with an x, hypotenuse is 2x, and our long leg is x times the square root of 3. With these three examples we're going to look at, again, they're actually all the same triangle, but we're going to be starting with different parts to see how we would treat the problem differently depending on what we're given initially in the problem. The easiest situation is if we're just given the short leg, because as we saw up here, everything's really based on the short leg. If the short leg is 11, we know that the hypotenuse is 2 times the length of the short leg, which would just make our hypotenuse 2 times 11, which is 22. Our hypotenuse is 22. Now the long leg, as we saw earlier, is just the short leg length times the square root of 3. So over here, my z is just going to be 11 times the square root of 3, which we can't actually multiply together because they're not like terms, and so we would just leave it as 11 root 3. Moving down to the next one here, again, same problem. However, we're starting out with the hypotenuse instead. Now earlier, to get from the short leg to the hypotenuse, we had to multiply by 2 times 2. So since we're going the opposite direction, we're going to divide by 2 to get to that original short leg length, which is of course 11. And then once you have that short leg length, you can move up to the long leg, which we know is short leg length times root 3. Same problem again down here, but this time we're starting out with the long leg. Now we know that the short leg, if we were going from short to long, we would multiply by root 3. However, we are going the opposite direction. And so this time we are going to divide by the square root of 3, the opposite of multiplying by it. So down here, I'm going to write down 11 root 3 divided by root 3. Again, in this one here, the root 3's cancel each other out, leaving us with just 11 for our short leg. And short leg, the hypotenuse, is multiplied by 2, giving us our 22. So now we've seen the same triangle starting with all three different pieces and how you would go about finding the remaining pieces. Now we're going to jump over to some problems on the worksheet itself. So here's number 4 on the worksheet for today for section 8.4. I picked this one specifically because on the problems that we saw just now on the examples, we saw a lot of canceling out of the roots, so we didn't have to do any rationalizing, but this problem here we're going to see is going to require some rationalizing. Now, this is a 45, 45, 90 triangle, so automatically we know that the legs, which are marked X and Y, are going to be congruent. So all we need to do is find one of them, and we know that the other one is going to be the same. Now, the piece that we are starting out with here is the hypotenuse. Now, since we know that going from a leg to the hypotenuse, we would multiply by root 2, we are going the opposite direction, and so we are going to divide by the square root of 2 to find that length. So over here, I'm going to write 4 over the square root of 2, which again, we can't divide those because they're not like terms. And additionally, we have an issue of a radical being in the denominator, and we've learned that we don't want that there. We have to use that rationalizing process to get rid of it. So I'm going to rationalize this by multiplying by that root that is in the denominator. So on the top, I've got 4 root 2. And on the bottom, that is the square root of 4. Because these are like terms, I can multiply those together. That square root of 4 on the bottom can now simplify to just a 2. And then you'll see here we have some numbers that are both outside of the radical. We can divide those since neither of those are kind of stuck underneath of the radical. These are like terms. And 4 divided by 2 leaves us with just a 2. So there is our answer, 2 root 2. That is our answer for y and also for x since they are congruent. I move down to number 7, which as you can see here by that marking of 60 degrees, this is a 30, 60, 90 triangle. And so before I start trying to find any values, I'm going to make sure I am clear on which side is the hypotenuse, which side is the short leg, and which side is the long leg. Now I know the hypotenuse is across from that right angle. Hypotenuse is there. I know my 30-degree angle is up here, so across from that is the short leg. And then our last side across from the 60 is the long leg. Now we can see that we were given information about the hypotenuse. We talked about these along the lines of the fact that the short leg is the most important, and that's how we can find everything else. So jumping back to the example we saw before, let's go up here. We started out with the hypotenuse of 22. We said, well, normally if we were going from short leg to hypotenuse, we would double it. We would multiply it by 2, but we're going the reverse direction. So we do the opposite of multiplication, which is division. We're going to divide 16 by 2, which doesn't involve any square roots or anything. It just leaves us with 8 for that value of y for the short leg. Now, hopping back over here again, we can see that going from the short leg to the long leg, we just have to multiply that value by the square root of 3. So I'm just going to write times root 3, leaving us with a long leg value of 8 root 3.